Well, hello again. Firstly, as ever, thank you for your comments and feedback on the last video. I realise that crankshaft balancing is a bit of a heavy subject, so I kept that one short. And now look forward to the next bit of work. And what I'm going to do is start thinking about the frame design and what I want to change, construction and everything else, because I found a good tube supplier of T45 steel tube, which is a sort of aerospace grade. It's often used in roll cages, that sort of thing, and it's nice and weldable, but it's as I say, it's a good grade of steel compared with the old tubing Triumph used to use. It's much higher performance, and I can afford to go a little bit thinner on the wall thickness, which will help towards weight saving, which is one of the aims of this bike that I'm building. So let's just go over the frame on this and the general chassis layout, and I'll sort of talk about what I'm thinking about changing. Right, where to start? I suppose we'll start with the more major things. Firstly, the wheelbase on a Cub is a little bit short for a trials bike. A typical ideal wheelbase is about 52 inches, and this is around 50, obviously depending a bit where your chain adjustment is. I'll try and run this near the back just to lengthen it. So I want to increase the wheelbase. I want to steepen the headstock angle slightly. It's at 65 degrees at the moment, and I'm going to bring that to about 67 degrees, pulling it in that way. That sharpens up the steering, lightens the steering a little bit. And other things, the swing arm is, at the moment, this is a standard wide Cub swing arm. It's very tight to get a 400 tyre in. On the non-drive side, there's literally sort of 3 mil of clearance, if that. So I want a wider swing arm with more clearance in front of the tyre, and particularly on the non-drive side, between the edge of the tyre and the swing arm, basically. Ground clearance on this Cub, it's about 10 inches, even though the shocks are longer and the forks are slightly longer. This one, it's about 10 inches, and I want to increase that to sort of 11.5, maybe 12, before you take any sag on the suspension into account. So basically I want a more ground clearance, and I'm going to go for oil in the frame. Obviously, well, this one's got a separate tank. Some trials Cubs use a frame brace with an oil tank built into that, but I want to go oil in frame, I suppose. I'm aiming to be as simple as possible, therefore simplicity, you will lose sort of fixings, nuts and bolts, bosses and things like that, so that will all help drive the weight down. Obviously the normal Cub frames have this brace in here because the tank used to be structural on a Cub and have the tube down here, but I'll just have a basic construction, more like a bantam frame, I suppose, or where you've got a welded tube to the top of the headstock coming down to the top of the seat tube there. Fork wise, I've had quite a sort of quandary about what fork to use. I had this pair of Sprite forks, a bit like Baby Sirianni's, about 33.5 diameter, quite light, and within reason you can do what you want with the damping inside. So I was going to use those, but the sliders will need rechroming, which is really expensive these days, maybe 200, 250 pounds. And I found both of the sliders, sorry, the stanchions, both the stanchions also are slightly bent, which again I could straighten, but not so keen on that. So there's actually quite a lot of cost in using those. The fork selection does affect the frame design, because with the Sprite forks, the steerer is parallel with the stanchions. On most Triumph forks, the steerer and the stanchions aren't quite parallel. There's about a 1 degree difference on these Cub forks, where basically the bottom of the fork is kicked further out, and that obviously affects by about that 1 degree. It affects your wheelbase, it affects what head angle you want, and so making the choice of fork before I actually sort of get into making the frame or designing the frame is quite important. So what I have decided to use is these BSA or Triumph 4 stud forks. They're used on a variety of bikes, not strictly pre-65. These are came in about 1970. These are what I had on the Tiger 90 that I built. You can do various things with the damping inside, but the good thing about these is they are plentiful. I've brought 2 lowers for about £25 each. You can buy new stanchions for under £100 a pair. You can even get high tensile stanchions that came off the Triumph Adventurer, some B40s, and I think even on some CCMs. So you can get loads of these parts. They're not a bad fork. There's some good mods online you can do to the damping to make them a little bit more suitable for trials. So that's what I'm going to use. I've managed to buy a Triumph Adventure bottom yoke, which is forged aluminium, so that's nice and light. And I'm probably going to make my own top yoke. One, because I'm struggling to find the Triumph Adventure one, but also you can get these stanchions without the tapered top that's used on most Triumph forks. Some of the later disc brake models of this fork had a parallel top, so that I think will make it easier for me to make a top yoke, and potentially you could adjust the length of the fork slightly by being able to slide it through the top yoke more. So that's my excuse me, that's my choice of fork, and as I say, that affects the frame design. So yep, I'm going for oil in frame, and similar to a RMAC or UPV frame, I'm going to not have a lower loop. Basically, the removable bash plate will be in about 5 or 6 millimetre dural high tensile aluminium, and just form a structural member at the bottom of the frame. That will help with increasing the ground clearance. It gives the bike a nice flat base to sit on if you're going over logs or hitting humps of soil or that sort of thing. Again, not strictly pre-65, but that's what, as I said, UPB do, AMEC do. I'm never going to be riding the Scottish, so that's what I'm going to do with that. I'm going to use 1.5 inch tubing down from the headstock to the top of the seat post and for the seat post, and I've already done some sums. That will give me about 1 litre oil capacity. I think that's the major items affecting my sort of choice and thoughts behind the frame design. Oh, hold that back a bit. Obviously the rear subframe I'm going to make myself. Oh, that is another significant point. I'm going to drop it down a couple of inches so the rear subframe's down here, make it narrower, and not have a loop going right over the back mudguard. Again, similar to AMAC and UPB frames. Just keeps it neater and lighter. Dropping the sort of standover height. Obviously I've got plenty of clearance to sit and stand over this here, but when you're on a 45-degree slope, suddenly it makes a big difference. I think, as I say, that's the major points that are going to be affecting my frame design. I've actually already modelled this existing sort of Cub rolling chassis and a scanned model of an engine on the CAD, so with dimensions taken from this actual bike here, and so I've got something that I can then compare with and modify and build up my own sort of frame. So I'm going to do some rough work on the CAD, get an idea of tube lengths and things like that, just to help me order and have some idea of what I'm doing before I actually start with getting the frame jig out and playing around with bits of tube. One thing I have already done, which seems a bit early to do, but I've sourced a pair of taper roller bearings for the headstock. I think they're 26mm ID and 48 OD. Again, seems a bit early, but the reason I've done that is I want to try and use a aircraft aluminium steerer set into the bottom yoke, and I wanted that to be a reasonable diameter, and effectively, obviously, what bearings you can get affects that. So I've got a bearing with a 26mm ID, so I'll be able to, in aluminium, make a reasonable diameter steerer. Other details like heavy things like wheel spindles, I'm going to again make out of an aircraft grade aluminium. It's just it's part of my sort of engineering exercise. What sort of weight can I get this bike down to? As I've said before, I'm not actually that much of a rider. Just enjoy building these things and enjoy the engineering sort of project. Oh, one thing I forgot to mention was the amount of trail on the front forks, which affects again the weight of the steering and how responsive or self-centering the steering is, the greater the amount of trail, the more it will self-center, but it will tend to be heavier. The less, vice versa, basically, be lighter and but will have less tendency to self-center. Therefore, on trials bikes, typically they have a smaller amount of trail. Trail is, let me just see if I can demonstrate it. The distance, a bit of paper on the floor, see if that helps, and a pen, between a line drawn through the centre of the headstock. So this is not an attempt to do an accurate measurement, but hopefully just demonstrate things. So a line drawn through the headstock, let's say there, and where that bisects the floor. So through the centre line of the headstock and where that bisects the floor. Then another line vertically down through the wheel spindle and where that bisects the floor. So the centre line of the wheel spindle and the contact patch on the floor is behind the axis going down through the headstock. And on this Cub, it's approximately, I think I worked out, around 108 millimeters. And when I fit the other forks and tighten up the headstock angle, that's going to reduce it down to about 80 millimeters. Again, making the steering a bit sharper, slightly less self-centering. Modern trials bikes, you're talking probably between 80 and 60 millimeters sort of trail, just to give you an idea. So just a little point I thought we'd go over. Another thing affecting the frame design, choice of forks, etc. The BSA 4-stud front forks will give us about 6.5 inches of front travel. These are barely 5 inches on these Cub heavyweight forks, which actually got Honda internals on them, but yeah, the BSA fork will be a considerable improvement. Also being 35mm leg, where the Honda internals here are about 32. Rear suspension, we've got about 4 inches travel on the back here with these NJB shocks. I'm going to go for probably some rock shocks, and I'll be looking to get about 5 inches travel by probably laying the shock down slightly more, bringing it forward to somewhere around here. So that's a quick talk over the bike. What I'll probably do is take you to the my office and show you some of the cab work that I've done, so that you can sort of start visualising the frame design. Thank you. So here we are with the CAD, and the first thing I'm starting with is the model of my current Cub. So it's not the dimensions of a sort of textbook road going Cub, but actually measurements, ground clearance, wheel size of outer diameter tires of my existing relatively standard Tiger Cub. And this really just gives me a starting point. This I've constructed by spending quite a bit of time just taking physical measurements off my Cub, and actually written down sort of quite a long list of various measurements, angles, and everything else to be able to create this. You know, if you didn't have CAD, I've done this sort of thing on paper before. Got books full of graph paper of various sketches and things like that. The CAD just it's a useful tool. Allows you to sort of three-dimensionally visualize. This is a three-dimensional model. I can move things around so I can get a look from all aspects. The sort of clunky looking image of the engine is actually a scan I did with my iPhone, quite an old iPhone actually, but a bit of free software allows you to walk around an object, scan it, and get a reasonable impression of its dimensions. You can see it's not perfect by a long shot, but actually if you interrogate this model dimensionally, sort of point to point between engine mountains, things like that, it's not too bad. And again, then allows you to start planning out the position of things quite usefully. So if I move on to a model of my new frame assembly, this is the start of it. So what I've done first of all is I started with the front wheel and set up a plane that represented the ground. Put the steerer in at the 67-degree angle that I wanted, and use that as the main starting point. These circles here and here represent the wheels at the full extent of the suspension travel. So I've then moved the engine into its approximate position, created a slightly longer swinging arm to give me this mud clearance I wanted, and started just to construct the tubes to get, principally to get an idea of length, because these are the things that I want to order. So this is the 1.5 inches that I want for the main top tube, seat tube, front down tube's a bit smaller, 1.25 inches. This line here represents the height of the subframe. So as I say, this allows me to start the basic sort of construction, look at making sure I've got clearance with the wheels at full compression, set up a plane here that gives me, I think, 11.5 inches of ground clearance, and I'll continue building the frame on from this. Other details I'll do, I will accurately model the engine sprocket here and a rear sprocket, just so I can have a look at chain line. I may want to drop this pivot down a little bit to give more clearance to the chain over the swing arm. Is that sort of thing I can look at here, which is useful to do. And if I model the sprocket in exactly the right position here, then I can also have a look at clearance I've got between the rear tyre and the chain. Potentially I'm going to move, although I've reduced the thickness of the engine here quite a lot, you can see I wouldn't have to move it a great deal to actually get the engine sitting slightly outboard of the swing arm pivot, which might be a useful thing to do to bring the swing arm slightly further forward, getting the swing arm pivot closer to the sprocket shaft, which will then mean the wheel travel will have less effect on chain tension. So that I will continue working with. And usually when I get to the frame jig, sort of then the first things I can do is I can basically set up the centres of the wheels on the frame jig, set up the front fork position and start building the frame from the headstock back. So that's the essentials of what I'm trying to do with the new frame design, and a bit on the CAD work complete, and the objective of that really is to get a list of tubing together and get that off to the tubing supplier, so get a quote and get that on order. So next bit to do is continue on with some work on those crankcases, and again to try and get those into a position where we can start thinking about building the engine. This video is going to be a bit of a mixed bag, because there's quite a few odds and sods where I'm waiting for material or tools to come in, and although there's boatloads of work to do, it's a bit about deciding what to do next. It's certainly good to get the frame material ordered so that I can move on with that, getting that sorted. But engine wise, there's other bits of work to do, and it would be useful to get these cases up to the state where I could basically build them. Well, there's need to be no more machining basically, and that would basically mean doing a bit of repair work on some of the threads I've got here, and the other significant difference or notable difference is with the oil pump. These are both twin bearing sets of crankcases, and this being the set I'm going to use because they're a really good fit with the main bearings, and this is another set that's slightly later, and here is where there is some of the differences. I want to use the latest oil pump, which is what you call the sliding block pump, which has this arrangement here and has a sliding block in. But there were quite a few changes done to this casing to make that fit. Let me show you. So the ones I'm going to use are slightly earlier, aren't currently intended to work with the sliding block pump. So if I bring this nicely into view and perhaps zoom you in a little. Yeah, let's bring it nearer. Here we go. That's fairly good. And just drop the sliding block pump into place, roughly aligning the holes, and bring them out to full stroke. What you can hopefully just about see is this wall here is been machined down with a relief in here to clear the end of the block at full stroke. When you compare it with the other casing, let's hold that up and see how we can do in there. You can see the machining in there. Cleared out probably 1/8 of an inch, 3mm down in here. Looking at the other casings, no machining in this area at all. So that's one bit of machining that I need to do. The other bit is the oil pump drive. Right, the oil pump is driven off this eccentric here, and this is basically the old distributor drive gear, which the oil pump was driven off the base of just here. And that's the old style for the old style oil pump, and you can see in comparison the later style for the sliding block pump. So obviously you've got this longer drive portion for the pump, and this diameter here is also larger, and that's to facilitate essentially a longer stroke on the oil pump, which is one of the things that gives it more capacity. So that also means this diameter bore, into which I don't know how well this will fit, whether there's burrs and things. Oh, it's starting to go. So this diameter bore here is larger than let's try and get that out, than the earlier models. There we go. So that would not fit into this bore here. Let's just take you out a bit. Come back. So on these cases I've got to machine a relief around here and increase the diameter of that bore. To do this bore, I've ordered a 5/8 reamer, which normally this shaft is 5/8 plus a thou or so clearance. So I will get the reamer, I'll make up a bush to support this end here that's a clearance, and then drill and ream out using that bush to get an alignment on that. Then, as I say, the other thing is then to machine the clearance here, and so that I'll set up on the mill. There is, luckily, see if we can sit clearer on that. There is a machined area here that I can use to get alignment that's parallel with the distributor drive bore, and also I can actually get a thickness across here and the machining one side to the clearance that's about 4.5 mil. So I can just align off that machining and mill in here until I get a thickness of 4.5 mil. So that's one job to do. The other one you've seen before is the inspection cover to access the sprocket there. And then I think with that cut out, the work done to fit the other oil pump, the restoration of these tapped holes, I think we are about there with respect to the machining on these cases. Oh, the other thing, what I will do, I've started to do, was cut out this area here just to give more access to cleaning the sprocket. I did that at an angle and left a bit of a web in there. Thought, oh, it might help support over here, but actually I've decided that's probably not needed, so I'm going to take that almost flush to this casing and then just bring it out across there, and just so that you can keep it clean when all the mud and muck and everything else builds up round the sprocket, which inevitably does. So whilst I'm waiting for tubing for the frame to arrive, that's what I'll be getting on with, as well as a little bit more CAD work on the frame, just so I've got more information ready to actually start building. Thank you. I'm setting up to mill this clearance in here for the sliding block oil pump, but to actually get the measurements I've put up the later type cases so I can clock up this bore and then pitch out and actually understand where this machine surface here and this machine surface here is. Now I've done that, written down the measurements from the crankshaft centre line to that surface and crankshaft centre line up to that surface, so now I know what I've got to achieve. I will put up the slightly older cases that need this relief putting in and get on with machining them. So that's the cases that need to be machined here, now set up true, clocking up on the bore for the crankshaft and this machine surface here to get it square. And the last thing I've got to do is just on these machined cases find out what radius we got in this corner roughly, so I know what size cutter to use. So got some good old-fashioned radius gauges, and let's have a little look, see what works in here. So let's have a look. That's 6 mil. Looks a tiny bit big. Got a little bit of a gap in the middle there, and flick through here. Well, that's 5.5 mil, and that fits really nicely there. So that means I want to find a cutter around 11mm, if not slightly smaller, just so we make sure we clear out enough metal in that corner. So dig a cutter up and then I can actually get on with machining. So that's getting there. Let's take a couple of measurements. Easiest thing, drop the table. Now, I should be in the region of 4.5 mil across here when it's finished. I am not necessarily down to finished size. 4.79, so that's not bad. So here we are, finished cutout now. I've checked my dimensions across the wall here, and that's all looking good. So apart from opening out this bore, which will be another operation, and I'm waiting for a drill and a reamer to arrive to do that, that's the necessary clearance done for the sliding block pump. So that's another little job done on these cases, getting closer to having those complete. Morning again. It's Sunday morning, damp and cold, matter of fact well and truly raining, and next little job to do on the crankcases is to do with the oil return from the cylinder head. So don't know how well you can see there, I'll have a check later, but around the valve guides, the pockets, there's drain holes so oil doesn't build up in the in these pockets to a level higher than the top of the valve guide and pour down there and cause lots of smoke. And the normal course is that these drilled holes here and here come through to the cylinder head face here and here, and then in the barrel, here's a nasty old one, you've got two drain holes running through the barrel parallel to the edge of the bore and come out just here and here on the face. And on the crankcases, so here's a set of standard crankcases, you've got these little scallops cut out for the oil to exit these holes here and here and return back down into the crankcase. The issue I have is with my new barrel, because there's a much larger bore and liner diameter. If I then get the new cases, or the ones we're working on, out, these have now been bored out to suit the cylinder liner, and those little cutouts have almost completely disappeared. Plus, on the cylinder itself, there's no drilled hole to get the oil down. So I've seen a couple of methods of getting the oil to the crankcase when people have fitted big bore kits. One of them is to do some sort of hole and fit an external pipe to the head, which I don't really like the thoughts of one having to try and do deep mods inside between the fins of the head. You're not going to get in there and weld anything, but what I believe most people do is basically return the oil down these around the edge of the cylinder studs. So I've done a couple of sums. We've got essentially an 8mm diameter stud, and we've got about a 9mm hole, and I've worked out basically if you take this hole out to 9.2mm, you get about the same cross-sectional area as these 4mm holes in the head. Well, actually, you get greater cross-section area than the 4mm hole, about 1 1/3 times. So what I'm going to do is, in the cylinder, open out these two holes, make sure I've got 9.2mm, so there's going to be enough clearance between hole and stud to get the oil down there. Can hopefully already see there's quite a lot of clearance there already. Then I'm going to, I'll just go to the cases, recut these half section, round section slots down the side of the cylinder, slightly repositioning, down the side of the crankcase throat, slightly repositioning them as well. And then finally on the cylinder, I'm going to, on these two holes, then mill away a little slot round here so the oil can come down between the bore of the stud hole and the stud, and then come out into this slot that I cut, and this slot will then sit over the top of the new cutout. So that's how I'm going to approach the problem, and it means another little job to do on the cases. And as I said, currently the cases are what I'm trying to progress so I can start building this part of the engine up. It will also mean later on with the cylinder head basically blanking off these two holes here and cross drilling from the cylinder stud hole and breaking in to this oil way, the other side of the blank that I will weld in this side. So quite a lot of work just to get the oil back down to the crankcases, but obviously it's got to be done, and when you're playing about with the engine, making them big bore and all that sort of thing, it's the sort of thing that you've got to do. So the first job I'm going to do, as I say, is set this up and machine out these half cutouts here. I've again done a few sums, worked out if I use a 6.5mm diameter cutter and drop it down so that half of it is on the edge here, then that will give me a cross-sectional area bigger than that 4mm hole in the head. So basically that way the standard bore in the head is going to be the tightest restriction to the oil returning, so shouldn't then be any issue with the oil being able to return. So hope you followed that. but next thing is just to work out dimensionally exactly where I'm going to put that, then get this back up on the mill and cut those two half round cutouts. Hope you followed that. Took me a little time to work it out, that's for sure. I've set up the mill to get this cylinder mounting surface all nice and flat and level, and clocked up the main bore where the cylinder sits to get me centres, and now I've got a cutter in and I'm ready to recreate these almost lost half round cutouts for the oil to drain through. Don't know how well you can see that, but I nipped on the CAD and just drew out the pitching of the cylinder studs, the bore for the cylinder to register in, and then the position of these two half round cutouts where I want them, and dimensioned it just so I've got nice simple coordinates X and Y from the centre of the cylinder, so I can just pitch out what I've got here on my digital readout, and then I should have the right positions to get these cutouts where I want them. I'm just trying to keep away a little bit from the threaded hole for the cylinder studs, just so I don't weaken that area. So that should be the position of the first one. We can just drop the cutter down, see whether that looks as I intended. Give a little witness mark. Yep, that looks good. So I'll move you around so I can operate things. Zoom you in a little bit. And let's see how we get on. And that doesn't look too bad at all. I'll do the other side. I might have been slightly better off just standing back slightly and then doing two cuts. The cutter was struggling slightly, but let's go and do the second one. So let's move around a little. And there we go, two finished new oil cutouts. Well then, that's been a bit of a mixed bag. I know I've got getting on for an hour of video now, so I think that's a good time to wind up this video. So effectively, importantly, I've got my list of tubing, and that's gone out to the supplier for quotation, and hopefully get that on order soon so I can really look forward to getting on with starting the frame. I've got a lot of other stuff on order at the moment. Bronze for camshaft and lay shaft blind bushes, steel for the head races in the headstock, drill and reamers for the enlarged oil pump drive shaft to do on the casings. What else? Spent a lot of money on second and third gearbox ratios. That's 2 pairs of gears, lowering second and lowering third to suit trials application. Sprockets, sprocket access plate. So there's a lot to arrive that will facilitate making good headway with the engine and making a start with the frame. So although it's been a rather bitty week, have actually made some good progress and look forward to moving on. So hope you found it interesting. Thank you for watching. As ever, your comments and feedback is always very welcome. So stay well out there, and I look forward to the next video. Thank you.